Welcome to this webinar. Before we begin the presentation, I want to provide you with a few housekeeping items. On your screen, you will see a taskbar with icons. Each icon is assigned to a particular element of today's webinar. Click on the person icon to learn more about today's speakers. Throughout the presentation, you can network with others or submit questions to the speakers in the Q&A and chat box next to the slides. Download resources from the cloud icon. After the webinar is over, please take our survey to tell us how we did. Today's event is being recorded and archived and will be available within 24 hours. For on-demand questions or comments, send us an email by clicking Need Help? Email us. If you experience any technical issues today, please refresh your browser by hitting F5 for PC or Command R for Mac. And now I'm excited to turn it over to today's moderator.
Good afternoon and welcome to Best Practices for Designing Modern Control Panels. This webinar is brought to you by Assembly Magazine and sponsored by Panduit. I'm your moderator, John Sprovieri, the Chief Editor of Assembly. Thanks for making us a part of your day. Today's presenters are Sean Whitaker, Michael Berg, and Marty Krones. Sean is Senior Business Development Manager for OEMs at Panduit. Michael is Senior Business Development Manager for Industrial Network Infrastructure. And Marty is Manager of Business Development for the Panduit product line, for the new Panduit product line, Prevention Through Design. Now, this is a live program, so please do submit questions for our speakers. Later in the program, we will address as many as possible. Today's event is being recorded and will be archived on our website, assemblymag.com. And now I'm excited to turn it over to today's first presenter, Sean Whitaker.
Thank you, John, and thank you to everyone for joining today's webinar. Before we begin our discussion of control panel best design practices, I'll provide a quick overview of our company. Panduit is a privately held company that was founded in 1955. From that time, when we first invented wiring duct, Panduit has grown to become a leader in the control panel industry, and today is over a $1 billion global manufacturer. Because of its strong financial position, Panduit is able to invest 8% of its top-line revenue into R&D, allowing us to maintain our leadership position with a comprehensive line of innovative electrical, safety, and network infrastructure solutions. Today's content, we will focus on 4 critical areas of control panel design, specifically space optimization, safety and risk mitigation, cable management and system reliability, as well as security and access control. The key learning objectives for today's webinar are 1, how to make more efficient use of limited space and mitigate noise when building increasingly crowded control panels. 2, how incorporating prevention through design principles can better protect workers from electrical hazards. And thirdly, how to accommodate more managed switches and networked devices safely in harsh environments with industrial Ethernet connectivity. So with that, I'll kick off the first discussion of design best practices, where I'll talk about noise mitigation and the effective use of space inside the panel. As we all know, electrical noise in a control panel can lead to significant problems. Specifically, it can cause field devices to misread the environment, devices to fail, reset, or enter a fault state, signal retransmission that can inflict communication delays, and in some cases, even equipment damage. Ultimately, this can be extremely expensive, taking the form of productivity losses, downtime, maintenance and repair costs, troubleshooting costs, device replacement costs, etc. These problems can be amplified by poor control panel layout practices, deficient grounding and bonding, and inadequate segregation of noise sources from susceptible devices and cabling. It's best to segregate noise sources and cabling, that is, components such as VFD drives, servo drives, switching, power supplies, etc., from noise-sensitive devices such as communications wiring, analog signal wiring, high-speed counting signals, sensors, protective devices, PLCs, etc. This is also referred to as zoning the panel. This can be seen in the three-zone panel layout in the picture, with the largest and most significant noise-generating components contained in the area outlined in black to the far right of the picture, with other noisy components contained in the area outlined in light gray to the bottom left, and lastly, the noise-sensitive devices and cabling contained in the area outlined in white to the top, where it is located as far as possible from the most noise-generating components. Another related good practice is utilizing different colors of wiring duct for color coding these zones. For example, white wiring duct for the clean zone, gray wiring duct for the noisy zone, black duct for the very noisy zone, and even blue duct for intrinsically safe areas. While distance separation can be an effective strategy to separate a few runs of commercial grade Ethernet cable from other wire classes, it becomes more difficult as the number of connections increase. Sometimes design or space limitations don't allow sufficient segregation of equipment and cables, and other solutions such as shielded cabling must be utilized. This can obviously add significant cost to the design. An alternative to this is shielded wiring duct or noise shield as pictured on the slide. These can be utilized to effectively and more economically provide additional protection. Use of these innovative products can reduce noise by up to 20 decibels or the equivalent of 6 inches of additional airspace. Now shifting gears a bit from noise mitigation to space optimization. As control panel designs become more complex, space is more and more of a premium. PanelMax DIN rail duct is a unique Panduit solution that can reduce enclosure size in new projects or gain space in retrofit applications. The picture on the left shows a typical control panel layout with alternating rows of DIN rail and wiring duct. This is done to allow wiring from the DIN rail mounted components to be fed and routed on both sides. The picture on the right shows this same control panel using DIN rail duct instead of traditional wiring duct. DIN rail duct has 2 channels, and the DIN rail is actually mounted on top of the wiring duct. This allows wiring from the DIN rail mounted components to be fed down into the channels on both sides. DIN rail duct is much stronger than traditional wiring duct, designed to easily support the weight of all of these DIN rail mounted components. The achieved savings utilizing DIN rail duct can be up to 30% in panel space savings, up to 25% in reduced material cost by reducing the cost of using a smaller enclosure, and up to 50% faster installation than conventional methods. By raising the DIN rail components up off the back plane, it provides better access to the components, which makes wire termination and labeling easier for improved assembly and troubleshooting. Another space-saving innovation from Panduit is corner wiring duct. Similarly as the last slide here, the picture on the left shows a more traditional layout of how the application is typically done today. In this case, 2 wiring duct channels are used to run wires vertically to connect the various horizontal wiring duct runs. These vertical channels must be moved out from the corner of the panel, though, to allow access to remove the duct covers and have access to the wires. Therefore, the corner is unusable dead space that's highlighted in red in the picture. Picture on the right shows how corner wiring duct can fit tight into the corner of the enclosure, replacing these 2 vertical channels to save mounting space in existing enclosures on both the side and back panel. This freed up space is shown in green in the picture on the right. By utilizing this previously unusable real estate in the corner, you can reclaim up to 20% of panel space to reduce the enclosure size for new projects or to gain space in retrofit applications. Additionally, it improves component access, easing wire installation and troubleshooting, and also provides a clean transition of wiring from the back panel to the side panels. So collectively, up to 40% total space savings is attainable using the Panduit PanelMax solution, specifically the DIN rail duct, corner wiring duct, and noise shield or shielded wiring duct. This can make the difference to retrofit an existing panel to include more components and prevent a redesign, or to use a smaller panel for a new design, which will ultimately result in material and labor savings of hundreds or even thousands of dollars for a typical panel design. And now I'll turn it over to Marty, who's going to speak to you about some best design practices relating to safety and risk mitigation.
Thank you, Sean. As Sean mentioned, our next section is going to be talking about best practices in regards to safety. And let's transition and think about safety from the standpoint of control. So what we're going to move into is a discussion around integration of safety into the control panels, beginning in the design phase, a methodology called prevention through design. Before we dive into how prevention through design applies to control panel applications, I want to take some time to review industry trends and key statistics in regards to electrical safety. These insights will provide proof of the need for advances in technology for electrical safety in North America. According to the Electrical Safety Foundation International, or otherwise known as ESFI, electrical injuries increased by 35% between 2016 and 2017. Although this statistic is concerning, it does not tell the whole story. As shown in the graph on the slide, the incident rate seems to jump up and down year over year. However, even with the existing processes and procedures, the injury rate trend has remained flat or increased from 2010 to 2017. This alone should be cause for concern, but these incidents are just the ones that are reported. Every year, many incidents are not even reported. So Panduit wanted to take this a step further and truly see how we can understand and support the challenges safety managers in EHS professionals face today. So in 2019, Panduit and EHS Today performed an extensive survey to further understand the common trends and challenges of safety managers as it relates to electrical safety. The data gathered from this effort resulted in many key survey results, including the next slide, which revealed important insights. So attempting to gain a broader perspective on electrical safety programs today, we polled safety managers and EHS professionals on what they are tracking and reporting when it comes to electrical safety. Over the past 5 years, nearly 7 out of 10 respondents had reported an electrical incident or near miss. This is not necessarily a bad thing. In fact, near misses can be a good thing. Reported near misses give organizations a prime opportunity to understand potential improvements and take corrective action. Unfortunately, 4 out of every 10, which is the second bar from the left, had officially reported electrical incidents over that time frame. It is also important to recognize that many incidents or near misses often go unreported. On the far right of this data, we see proof of this, with 8% of the safety managers saying they don't even track electrical incidents. Not only could the number of electrical incidents be higher, but these organizations are also missing the potential opportunity to track this data in order to potentially improve their safety program. If we look in the middle bar, finally the 40% who report an electrical incident, just under half, or 18%, of the total surveyed reported that their incidents were related to electrical voltage testing. This finding was particularly interesting as it directly aligned with a study published in an IEEE journal in the late 1990s around voltage testing incidents. This provides credibility not only to do voltage testing voltage testing incidents account for a significant chunk of electrical incidents, but it also shows that these type of incidents have not decreased over time. Keep this specific type of electrical hazard in mind as we look for ways to improve electrical safety within control panels and other electrical enclosures. So let's get back to prevention through design. So the methodology called prevention through design is becoming top of mind within the North American industry. The main idea is to proactively address hazards and risks in the design phase of equipment rather than reactively following the factory floor deployment. The European market has committed to this approach for years and consequently has reduced many of the incidents associated with electrical hazard. Next, we will discuss what this methodology looks like and solutions on the market you may consider for risk mitigation using a prevention through design approach in control panels. So the hierarchy control is a systematic method of mitigating risk in the workplace, and it's the controls that are used and associated with prevention through design. All 5 of the stages of the hierarchy are elements of a robust safety program. One of the principles of this methodology is to look for opportunities to move up the hierarchy, since this will increase the effectiveness of the control and consequently better mitigate the hazard. For example, the lockout tagout procedure is a very important practice that would fall within the category of administrative control, relying on workers to follow procedures and the proper steps of lockout tagout. Deploying a technology that enhances the lockout tagout process, or is controlled through an innovative device, can raise the lockout tagout process from administrative control to the engineering control, a step up. The result of this effort would deliver a more effective means of mitigating the hazard to the worker. So let's take a look at a new device category that enhances the lockout tagout process and has the functionality to move up the controls hierarchy and contribute to setting the direction of the future of electrical lockout tagout. So this comparison shows the historical method of verifying the absence of voltage in the image on the left using a handheld voltmeter. On the right, the image on the right is a comparison to show how a worker could verify the absence of voltage using the VeriSafe absence of voltage tester. The absence of voltage tester is a new testing device, otherwise known as an ABT. It is a permanently mounted device intended to verify the absence of voltage. Using VeriSafe, a qualified worker can perform the verification task outside the enclosure, mitigating the risk of exposure to the hazards inside while improving efficiency. The ABT also reduces reliance on human factors by automating the live dead live test sequence with the activation of the push button. The ABT is also capable of communicating with other components, for instance, an electronic lock. There are output contacts on the device itself on the isolation module that's mounted inside the enclosure. And these output contacts are also within the scope of the functional safety rating of the VeriSafe device. And they change state when the absence of voltage condition is confirmed. These output contacts can be used to interface with the Panduit electrical lock assembly or other devices to lock or unlock an enclosure. This elevates a conventional lockout tagout program from administrative control, relying on workers to follow procedures and guidelines, to an engineering control that automates the lockout tagout procedure. Ultimately, this mitigates the risk with an added layer of protection by preventing enclosure doors from being opened until the absence of voltage is confirmed, eliminating human error or shortcuts while saving time. These contacts may also be interfaced with a PLC for a time date stamp or for other purposes when the absence of voltage condition is confirmed and for use with other use cases and ideas. Finally, for prevention through design and control panels, another device that provides a through door interface to the equipment inside the enclosure are Panduit data access ports. These devices are permanently mounted programming ports, allow users to safely and securely access PLCs, variable frequency drives, and industrial networks within their equipment. Data access ports provide this access to hardware within the panel or equipment without having to open the panel door. They're able to provide many types of connection means, such as Ethernet, USB, different type of couplers, and they utilize Panduit Minicom couplers and jacks. These data access ports were designed to be completely modular, allowing for ultimate design flexibility, field upgradability, and adaptable inventory. Additionally, power can be made available on the panel door to keep a computer or laptop charged during the maintenance or updates. Security provisions such as a quarter-turn lock and padlock loop prohibit unintentional unauthorized use of the programming port or power. The Panduit data access ports are also UL listed, which allows for simplified and comprehensive compliance. So at this point, I'm going to turn it over to Mike, who will cover the last section of our presentation. Mike?
All right, thank you, Marty. Glad to join everybody today. And this is Mike Berg, and I'm going to talk to you about the best practices for control panel design as relates to your Ethernet connections and networked devices. So looking at applying Ethernet at the control panel, there's three real areas of concentration. The first and most primary is electrical safety and planning the wiring and the cabling components accordingly for Ethernet, and that's an area we're going to focus on today. The second is really understanding those environmental conditions at and around the machinery, some of those concepts that Sean talked about earlier about segregating components for noise mitigation also come up very much with the Ethernet design. And then finally, the design, installation, and commissioning practice that is optimal for the Ethernet system, because Ethernet's connected at that control panel level, the edge device level, but it connects all the way back to the enterprise as well. But for today's conversation, we're going to talk about control panels specifically. So the state of the network and what's going on with Ethernet. Why do we need to be so concerned about industrial Ethernet in the control panel? Ethernet is growing at a fast pace, as you can see here. It represents 59% of all the nodes on the plant floor in 2019, and it's growing at a 20% pace. So what's driving this, right? It's really the simplicity to implement Ethernet along with the ability to pull that device data and connect it back to the enterprise. Those are the key drivers behind why Ethernet has become this dominant protocol. So the presence of Ethernet devices and those industrial managed network switches is increasing and becoming very common in the control panels today. In fact, multiple devices within a control panel is very common. So you're starting to have to plan better for how those Ethernet cables are routed. So because Ethernet is so widely available, misapplication of the Ethernet cabling happens frequently. Most people know, not to use an indoor power cord for their Christmas lights. Doesn't usually work out so well. But they don't always know about the Ethernet cable. They don't know whether that cable is right for that application or not. So recognizing the right Ethernet cable, the right jacketing and cable construction is very difficult to do on the plant floor. This leads to misapplications and poor installation practices happening on the plant floor, which presents a risk of electrical shock hazard and may actually be in violation of the electrical safety code. So the type of Ethernet cabling used for controls applications is important to electrical safety. And here's some things you should consider. The sources of power and high horsepower motors are typically nearby, somewhere in the area down at that control level, machine level. And power and data devices and cabling are almost always in close proximity within the control panel, and that's where they're all terminating. And it's very difficult to design around this, as you all know. So informed cable selection and applying best practice installations are the key to code compliance and really to reliability and performance as well. So I want to talk a little bit about Ethernet product grades. A great thing about Ethernet is that it's universal and it's standardized, and anywhere we go, we can connect, right, with the RJ45 connector. In your home, you're probably using Ethernet for your internet, your TV, your smart appliances. In the enterprise or your office, the Ethernet connects to the office and the retail space, and on the plant floor, Ethernet is becoming more and more important in connecting switches and devices, as we just talked about. Each of these locations use specific cabling types based on the required application. You may not be aware of it, but you need to specify and use different grades of cable to fit the application, just as you would any other electrical wiring. And what this really comes down to really is the jacketing and the cable construction of these different grades of cable, right? And learning to discriminate between those. So if we look at the different applications as we have them here, with a residential cable, it's going to be light use, right? You're not going to have as many changes in your home network. And importantly, from a cable construction standpoint, you're going to have a connector on there, and you're not necessarily going to have the best insulation on that cable jacket. You may have as little as 80 volts of insulation protection in that jacket, which is important. When you look at a commercial grade cable, commercial grade cabling is made for routing in commercial spaces. It's made to be routed in pathways, so there's going to be some accommodation for routing with power, right? It's typically going to have a higher insulation voltage rating on it of about 300 volts. It's going to be made more durable, a higher level of connector, higher level of cable jacketing used for a longer life and longer quality, and it's likely to be factory tested. And what that means is not only is there a wire map happening, but also the communications testing is done as well. So there's a Cat5e or Cat6a test done on that cable to verify it can be used in a system without having to test that cable in the field, which is a big advantage. Now, when we come to the industrial grade cables, we're in the harshest of environments, right? We're in a high noise environment. We may have other factors going on with temperature, vibration, and other factors coming in as well. So we need a cable that provides that Ethernet connectivity, but we know it's also going to be routing very closely to power, and this may be even a higher grade of power than in a commercial space. So we may need up to a 600 volt rating on the insulation of that cabling. We still need that durability, long life, and quality. We would prefer to have a cable that is made for this space as well, an appliance wire type jacket, and the quality of the cable as well, including the ability to have shielding in that cabling as well that mitigates the noise that happens on the plant floor. Okay, so where that takes us is how does that cable construction play into the suitability and the safety codes in your control panel? So we've listed out a couple of the safety codes and the standards of application that come into play. So the primary governing code is the NEC 725, where circuit classifications apply to the control and information circuits. And what 725 does is it outlines those wire classes, which you can see in the blue box there. So it designates what a class 1, a class 2, or a class 3 is within your 600 volt rated cabinet. So the 600 volt industrial rated cable is going to correlate with a class 1 circuit or class 1 wiring. So the standards of application, UL 508A and NFPA 79, they'll also reference these cable classes and the wire segregation methods. Standards of application supports what's in the safety code. So as I was talking about insulation voltage on the previous slide, the insulation voltage rating helps us to determine what the wire class is so that we can discriminate between those different cable types we have, and it helps us plan for the routing and wiring of that cabling. If we're routing with the same class or if we're routing with mixed classes, it helps us determine how we're going to set that pathway. So in the control panels, we have options for what cable we're going to use and how we're going to route it. The 600 volt cabling provides the greatest design flexibility, being able to route safely with other wiring within a 600 volt rated enclosure. This eliminates that need to separate the cabling or plan separate pathways for Ethernet in most cases. The 600 volt cables and cord sets will also typically be marked on the cable, so it'll say 600 volt for easier identification, easier routing, easier inspection as well. Now, it's also very possible, depending on your enclosure design, to use the Class 2 cabling or the 300 volt rated Ethernet cabling. This is especially true when all the cabling within that control enclosure has a maximum voltage of 300 volts. That allows you to use all in the same class and without a concern. Or we need to plan for the pathway so that we avoid mixing those wire classes within our enclosure. So it's also very possible to use that commercial grade 300 volt rated cabling. Panduit supplies both those industrial 600 volt rated cables as well as those commercial grade cables as well. So outside of the enclosure, just want to make reference in terms of NEC section 800 as well as NEC section 400 reference the industrial cord sets and cables routing outside the control panel. So 725, 800, and 400 are all key sections that reference in the safety code. And just to kind of give you a quick overview of what the standards are relating in the control panel space, the left two tabs kind of are electrical safety standards I was just referencing for the US and for Canada and some of the international standards as well. And then on the right-hand side, the cabling and component standards. These are industrial Ethernet premises standards, which are the cabling and connectivity standards for structured cabling across the plant floor. So these standards control the cabling connectivity and performance standards across the plant floor. All right, so hopefully this has been helpful for you all. And at this time, I think we're going to turn things over to John, and we're going to go to a Q&A session.
All right. Thank you, gentlemen. That was covered a lot of ground there in a short time, so thanks a lot. Before we take questions, I'd like to invite everyone to take our survey after the webinar. Your feedback will help us improve our programs. As usual, we do have a number of questions coming in, so let's get to it here. Tim wants to know, does the panel Ethernet power connector unit come marked for computer use only? Michael, do you want to take that one?
Yeah, John, would you mind repeating that one more time just so I can hear it again?
Sure. Does the panel Ethernet power connector unit come marked, quote, for computer use only, unquote?
This is Sean. I think I'll take a stab. I think they might be referring to the data access port, the Ethernet ports there. And yes, the product is marked for computer use only, if that's what they're referring to, and I believe it is.
Okay. Okay.
Thank you, Sean.
A question here from Marty. Have the electrical gear OEMs adopted very safe AVTs where very safe may be selected for factory installation into controls and power distribution equipment?
Yes. So Rockwell Automation, they have it integrated into their MCC lineup, their 2100 series MCCs, so you can spec in VeriSafe as an engineer to order selection, and it's within their fast track program. It's also a specifiable item and a configurable item within Schneider motor control centers, and then also within their low voltage switchgear, and at Eaton as well is integrated into their motor control centers and is part of their engineer to order options, and other OEMs are considering adoption as well. So, and in addition to that, the VeriSafe can be used not only with motor control centers, but a number of other 600 volt rated power distribution or controls and below, and it looks like that's going to scale within the OEMs that we're asked about. So, so it's a long answer to a short question. Sorry.
Okay. All right. Jesse here has got a question. In my field, we do a lot of troubleshooting. Does the DIN rail duct make troubleshooting easier or more time consuming? Sean, you want to take that one?
Yeah, I'll answer that. You know, it's our belief and feedback we've received from customers and users of it that it actually makes it easier. As I mentioned, because you're pulling the DIN rail and DIN rail mounted components as well as the cabling kind of away where it's easier to access and work on, it actually has feedback says that it eases troubleshooting just with the gaining of the access, improved access to the wires and the components.
Okay. Another question here for you, Sean. Kevin wants to know, does the wire-away DIN rail come in different sizes, or is it one single size?
Yeah, I should have mentioned that, so I appreciate the question. It actually, we offer it in 3 sizes. As I mentioned, it's a dual channel design, so there's 2 side-by-side channels. We offer that in a 2x2, so 2 inches by 2 inch. Each of those channels is 2x2. We also have a 3x3 where you have the 2 channels, each 3x3 in size, and then also a 4 inch by 4 inch version. So 3 sizes, 2 inch, 3 inch, and 4 inch are available. It's also available primarily in gray, but other colors have been asked for as well.
Okay. Another question here for you, Sean. This one's from David, and he asks, when using the DIN rail wire duct, does it still provide a direct ground bond to the panel, or are separate dedicated component grounding runs required?
Yeah, it is a plastic design, so it would be same as traditional wiring duct in that regard. So yeah, you would have to do whatever grounding methods you would use, especially if you're using shielded cabling, those type of things. You would still have to ground that as you normally would. It basically just mounts directly on the back plane of the panel using metal screws. So you would still have to do grounding as you normally would with traditional duct.
Okay. Question here for you, Michael. Is the 600 volt rated cabling essentially the same commercial grade Ethernet cable, but with a higher voltage rating?
Yeah, in some cases, the cable, the conductors inside could be similar with a different jacketing, right? If you have a UTP style Ethernet cable. In many cases, though, you're going to have a different style jacketing, the appliance wire material jacketing, and something that might be oil resistant. And you probably are going to have some layers of shielding inside of that cable. And the shielding is going to be designed for the plant floor. So it's even a little bit different than your common commercial grade.
Okay. All right, we're back to you, Sean, here. A question. Do you get many requests for halogen-free ductwork?
Yeah, we do. Obviously, that's more, somewhat regional. Obviously, we get a lot more requests for that in Europe and other places. But yeah, even in the United States, we do get a number of those requests, and certainly that's an increasing and growing request that we get. The good news is we already do offer a full line of halogen-free wiring duct, so that is an option that's available in our traditional wiring duct in a halogen-free grade as well. So that is something we currently offer.
Okay. All right. Don't go away, Sean. Here's another one. Edward wants to know, what is the delivery time or availability for DIN duct in colors other than gray, since you mentioned it?
Yeah, primarily that's offered in gray. We have done it in the intrinsic blue, but certainly that's more of the exception. So to that point of the question, certainly lead times would be increased and volumes required. Beyond those colors, if someone were to want white or black or other colors, that probably wouldn't be something that we could entertain without some significant volume. So primarily, again, I would say, stick with the gray as our standard product. If there is interest in other colors, certainly we want to hear that and we can entertain those. But certainly from a availability, price point, all those things, gray is the standard product.
Okay. Another question here about the DIN rail duct, generating a lot of interest here. Nolan asks, is the DIN rail duct, DIN rail, is that plastic? Is that made of plastic?
Yeah, another good question. So actually the DIN rail is standard metal DIN rail that you would use normally. So when we ship our wiring duct, it does not include the DIN rail. It's compatible with the standard off-the-shelf DIN rail that you're already utilizing. So you would use your existing DIN rail and then mount that on top of our wiring duct.
Okay. Okay. All right. Question here from Michael. Would I ever use both shielded Ethernet patch cords and a shielded duct in the same application? Would I essentially get further noise mitigation?
Yeah, that's a really good question, and that pulls upon things that I talked about, and also what Sean was talking about, where Sean was showing those noise shielding wiring ducts. So if you do use multiple layers or levels of shielding, they will actually provide you additional protection or additional noise reduction. That would be common, like in a situation where you're having noise problems. You may already have a shielded cable, but you need to resolve that noise issue. You may add something like a shielded duct or that shielded barrier to provide you just that additional layer of noise reduction, which may help resolve your issue.
Okay. All right. Plenty of time for questions, folks, so do keep those coming. Here's another question here. Michael, if you want to take this, when am I likely to be asked about the wire class rating of the Ethernet cord sets in my panel?
So when you're likely to be asked about this is, it probably comes up at the design stage, but then it also is going to come up when the panel build is happening, especially if you're a UL 508A shop. At some point, there's going to be an audit or an inspection of your project, and this may be one of the things that the electrical inspector asks you about. What's the rating on this cable? Can you tell me the insulation voltage rating? If it's marked on there, they can read it clearly and they can move on, or they may ask you for paperwork on the cable to verify what that insulation voltage rating is. So that's when it's likely to come up.
Okay. All right. Well, if there are no further questions, then we will wrap it up. Please join me in thanking Sean, Michael, and Marty for their presentation, as well as our sponsor, Panduit. If you've got additional questions or comments, please click the Email Us button on the console. Please visit webinars.assemblymag.com for the archive of this presentation, as well as information about some of our upcoming events. We've got some webinars coming up on product design, lean manufacturing, and digital manufacturing. So I think you guys are going to want to tune into those. Thanks again, everybody, and have a great day.